Looks like we have 12 people here. Did you guys at least get outside a little bit over the weekend? It was pretty nice out. Good.
No. Oh, Jennifer, very sad.
And now it's starting to get so hot.
I'm not an outdoor person.
Uh-huh.
So I did the assignments and then I did white collar binge watching marathon.
Is that a show?
Yeah, with Matt Bomber and Tim
Oh.
DeKay.
Okay, cool. I'm going to write that down. I'm always running out of good.
Well, it's only 6 seasons, but it's amazing.
Okay.
It's on Netflix.
Cool. I'm going to check it out. I have a list of shows that I'd like to watch. Somehow I never get around to it. There's always stuff to do, but it's like, you know, at the end of working hard, you want a little reward, a little time to unwind. Yeah.
Maybe when I graduate, I'll have time for TV.
I know.
How many classes are you taking, Tanya?
Well, I just do one at a time. So I have this one, and then I just registered for my final class, and I'll be done.
Wow.
Almost there.
That's right. Registration opened today, right?
Yeah.
Yes.
It did open today.
I'm
I
in
was
the same
watching.
book as you. I got to book that class.
Yeah,
All
I'm with you again, Carrie.
All right. Data science. Cool.
Yes.
Oh, that's good. It's going to be great. So that one's a lot more project-based, less on skill development. So we use a lot more, maybe I'd say more built-in tools, but we're dealing with more of the higher level concepts in that class and putting together projects.
It's still very scary. It doesn't matter.
And if anyone has issues registering, when I was registering, it threw me an error, and I reached out to my advisor, and they said they're aware of errors on their end, so he was able to push it through for me. So if anyone runs into an error trying to register, just reach out to your advisor.
That's what they had to do for me too. They required a prerequisite number showing that I did all the other classes. So he had to override it for me.
Well, thanks for sharing that. I don't get a lot of insight into that process, but you're absolutely right that reaching out to the advisor is the way to go. They are helpful. Who do we have? We have Caitlin, Angela, Laura. Is there anyone else?
I have Matt.
Matt. Okay.
I have Matt as well, my new advisor. He's my third one now.
Okay.
Yeah, he's my second because the other one went on maternity leave.
Yeah, that was Laura. Okay, good. We all know each other. We're all friends. We're like this little family in MSBA program. Yeah. Okay. Okay, so now we have 14. Some nice words of encouragement. It's good. I am going to go ahead and get right into the assignment like we did last time. I will be sharing plenty of additional concepts, and you know what tends to work well for people is we go through the exercises and explain some stuff along the way and talk about kind of some different use cases. The big theme of this last week that we've come through is this idea of a function and creating a collection of operations that we can use over and over again with different inputs. Okay, so there's a lot to kind of organize in your mind and separate. It's also really challenging to build a function from scratch, right? That's you know, something you might not expect to do in the business school, right? But knowing how to do this will give you a huge advantage, because I think you'll see, even though you can go into data science and data analytics and use a lot of the built-in tools that are there, they can do a lot for you, but it's a lot like a black box. So understanding the inner workings is really helpful. Knowing how to build a function can help you take the operations that are already available in Python and then turn it into something really unique and customizable. So this is a step in that direction. Okay, so we will look at different types of functions. We will focus on some of the new topics that we've worked on. This idea of a function parameter that can be changeable. We'll revisit that from last week. We'll take a look at using print statements versus return statements. And we'll see an example where we actually do both, right? So those are two ways to output something from a function. And which one you choose kind of depends on your goals, what you want to do with the output of that function. So there's no hard and fast rule about when to use a print statement in your function, when to use a return statement in your function. So that's one thing we'll look at. We also are going to take a look at default arguments, how those can be used, and we'll do the calculate bill problem. That's always one that people ask about. So I just know we're going to want to do that. People also ask about problem 3, because that has a lot of steps that, there's a couple places where you can go wrong, but one of the themes of that function is using functions within other functions. So that's a big theme there. And then from there, so I'd like to do those 2 problems for sure. And then from there, we can go over anything else that we have time for. As long as there are questions, we'll stay and we'll keep working. So does that sound like a good plan? And is there anything else you'd like me to add on to our strategy for this session?
Do you mind? Problem 1 seemed very simple, and I thought I got it, but CodeGrade rejected it. Do you mind just reviewing that real quick?
1.
Yeah, I mean, I thought I was fine with it, and then CodeGrade rejected everything. I was like mortified last night.
Well, let me just remind us about that situation. So I did have a chance to look at your code because you had asked me a question, and you don't have, what it looked like to me, I didn't see a mistake in problem 1. What happens when we submit the file to CodeGrade is if there's anything in the file that isn't working, then all the auto tests will fail. Right?
Oh, okay.
Right. So we see that happening, and the lower it is on the page, the better we can feel, because that tells us that if we look at the auto test, right, and it says here's where the code is going wrong, and say that code is in problem 4, then okay, well, there weren't any errors up till problem 4. So the first issue that was encountered happened in problem 4. So resolving that will clear that error. So I would say there could be additional errors, or there could be other cases that are not matching the expected output. But working through and clearing that error should alleviate the issue. And then, if there's an error lower in the CodeGrade will find that and point it out. If not, we may just, maybe everything will work if we correct that error, or maybe we clear that error and there are no more errors in the file, but maybe we have some tweaks that we have to do, some mismatches in output. So the first step is always to clear all the errors. And sometimes they'll show up in Colab, sometimes they won't. So one thing I tell people is let's run everything, right? Do runtime and then run all right before you submit your assignment. Once you've filled in all the blanks, runtime, run all, that'll catch errors. And then then you can submit it to Code Grade from there and see what else comes up. So
Now, when you say runtime, run all, you mean in Google Colab, run everything?
yeah,
Yeah, I did that, but yeah, maybe when we have our one-on-one, maybe you can show me, I'm not sure how to read where the error is in Code Grade. Because it looks like there's an error with everything, because everything's marked wrong.
Yep. So let's actually go there. I've anonymized all of these, so
If you want to pull mine up, that's fine.
yeah, that's very nice of you. I just randomly pulled up the first one that I saw that I can tell has an error. There are several, because we're not at the assignment deadline yet, so people are turning stuff in and finding the errors that way, and that's what I expect to see. Okay, so basically, when the assignment is submitted, we have this auto test tab. And so in the auto test tab, we can see some code from the assignment itself. And then there's a lot of surrounding code. So this is an outcome of our class. We work on reading errors. It takes some time to get used to that. But what we see here is that the calculate bill function is missing one required positional argument cost. Okay, so that's not giving away the whole answer on how we need to fix this, but it's getting us closer. So it's telling us, well, that the calculate bill function needs attention. So something's happening in problem 4, and then we can go to problem 4, and then I can see, okay, well, actually I want to, okay, now I'm a little struggling here because I don't want to give this all away. I want to work through this problem with you guys. So I'm not going to show that code.
Okay.
I'm not going to show that code.
But yeah, I was confused because it's showing that code that you're reading is showing next to problem 1. That's why I was confused. Okay.
Yep, so that'll always happen. Everything in the file has to run in order for everything to run. So yeah, that is definitely makes it a little harder to read, but we can usually figure it out. Like we can usually see, okay, well, this code's coming from problem 4, so that's where we need to concentrate our efforts. Yep, so that'll always be the case with the assignment.
So will it tell you where there's additional errors, or will it just stop at that first error it finds?
It's just the Python interpreter just gets shut down after the first error. Yep.
It's all a learning process here.
It's very iterative. It's totally, we have to make so many revisions. And yeah, being a programmer really, or analyst, involves being wrong most of the time. And that's very uncomfortable. I found that uncomfortable when I first started programming in R, and then in Python, it's just, you're just wrong most of the time. Because once you get it right, you're done. There's nothing else to do. I mean, there's maybe some tiny things you can do to improve the code, the style, the efficiency, that kind of stuff. But yeah, so a huge portion of our time is just spent resolving errors. And that's a good thing to learn how to do, but it can be pretty jarring at first for people who've never programmed before. Okay,
I feel a little better than knowing that, because I thought I tanked the whole thing, and I was like, I give up.
No, you'll start to see, okay, well, that didn't work, fix that one thing. And then I've worked with so many students early on in the class, and they think, oh my God, everything's wrong. I'm just going to give up on life. It's terrible. I have no hope. And then we add an extra closing parentheses on the end of a line, and everything runs perfectly. And they go, oh my God, okay.
Oh yeah, those parentheses last
night I was like, oh my God, I am so close to graduating and I'm going to fail this class. Like, I'm not going to get there.
Yeah.
I was horrified.
some people get in that fatalistic mindset, right? This doesn't work, so I'm gonna give up. But you'll see. It takes some time. And this class is set up in a way that you really can't fail if you're doing the work and making the improvements on the assignment. So there's no need to worry.
I didn't give up. I just reached out with a screaming help.
Perfect choice. Perfect. I saw a hand raised, and then it went.
Yeah, I was gonna ask. So when we're writing the code in Colab, I understand the need to do the run all, but if you run the individual segment of code and it doesn't return an error, is it likely to throw an error when you upload the file to CodeGrade as well?
Likely not, but you may get mismatches in output. Okay. So if the code runs in Colab without an error, usually it's going to run in CodeGrade just fine. I can think of some cases where that may not be true, and I'll tell you about that. But basically, let me tell you the things I see most often. So the biggest issue that I see in the assignment submissions, especially at this stage, is the cases where the function parameter isn't defined or isn't referenced correctly within a function. So in other words, somebody wrote a program that only works for one sample case, like this one. So we may end up doing this problem together. Yeah, let's go to that. And let me just say, okay, so Colab. Colab is extremely useful. It's a great interface for us to learn and develop code, but the way the code runs in Colab is not the most realistic. So most of the time with any computer programming language, you write a file of code, right? You write your code into a single file, and the interpreter, which remember is that mechanism that translates your code into the language of a computer. So that interpreter will read your code, and it will run all at once in sequence from the top of the page to the bottom of the page. So that's not how we tend to work with our code in Colab, because for learning, it makes a lot more sense to write small individual programs, right? To segment it into these code blocks so we can run it a little bit at a time. So that's great for pedagogical reasons and for learning all these different features and just having the information more organized in our minds and in front of us. But then there's this transition that happens when we bring our file into CodeGrade. It runs from top to bottom in sequence. It runs for the very first time, meaning that the variables are only defined once. And they're defined in the order that they appear vertically from the top of the page to the bottom of the page. So there can be cases where, for example, you define a variable in a code block in Colab, right? So I say name equal Tina, and then maybe I can do this in Colab. So I can run this code block right here. I just ran that, and I can then do something that I cannot do in CodeGrade, right? I can write a code block above this, and I can say name, and then it tells me the name is Tina, right? When I'm running the code in Colab, I can run these code blocks out of order and store information on the server that is supporting this file, right? So that gives us a little bit of an unrealistic idea of how the code will run ultimately, right? So what the takeaway is, right? What you want to keep in mind is that you never want to have a variable referenced above where that variable is being assigned or defined, right? So this is not a good practice. We want to avoid that. So I'm going to delete that. That's the one case where I've seen errors that didn't show up in Colab, but then show up in CodeGrade. So having the variables defined, having a variable referenced before it is defined. So that's one issue.
Now, another question for you. I've been adding text blocks along the way, like if I had a question about something, is that going to throw an error when I load that?
No.
Okay. And then I've also added code blocks, like if I wanted to test something, I've added another code block. Will that throw an error when we upload?
Well, only if you do what I just did, right?
And put it out of order.
Yeah, so that's a great practice. I mean, writing the text to annotate your notes it's a terrific thing to do. The text or comments is not going to do anything at all, so you can do that as much as you want. Adding extra test cases is an excellent idea. I would just make sure that anything that you reference in the file is defined before it is referenced, right?
Okay.
So the correct thing to do, if I have name equals Tina, define that, then reference it in a code block below, not above.
Okay.
Yeah. Yeah, thanks for asking. That's good. Okay. Okay. So I wanted to use actually this problem right here, problem 1B as an example. And then I'm going to go over this idea of a parameter reference, correctly referencing function parameters. Okay. Yeah, so I'm going to call this, I'm just going to call it a string, but I'm just going to use the word stg, short for string. Okay. This is a function, so I've now completed the function definition line. I've given the function a name. I've given the function a parameter, right? It says parameter there. And then I've closed the function definition with a colon. Okay, so we saw this a little bit. We saw that we could create a function. Some people were using format strings. I won't do that because I don't cover that. But we can do this pretty simply by writing out the phrase that we want to output and including that variable. So the string is going to be the variable that's the changeable part of this function, and the output I'd like to see is this. Tina can't get enough Python, my kind of stupid little thing that I made up, but that's okay. So now I'm going to add the string portion of this. Oh, I need capital. And there. Okay, so I have this. And then I define it. I need to run the function. So to run the function, I just do statement arg. And then here's where I need to input the value. Okay. Okay, so now I have the expected output. Okay, good. Well, as Tanya was saying, it's a good idea to try some extra sample cases, and I'll do that right here. So I could say Enzo, and let me call this, just, you'll see why I'm going to do this. So this is going to be another name. This is my cat, one of my cats, Tina and Enzo. So now, with a new input, a new argument to the function, I can see that the output adapted accordingly. Okay. Let me also say that there's no reason why I couldn't do this, right? I could also type in the name exactly as it is stated, and I would still get the same result. Okay. So what you do doesn't necessarily matter, although as you start to build more and more functions and more sophisticated programming, you will find that defining your variable outside of the function call may have some benefits, because then you might be able to easily change it. Also, people say it's sort of better to be able to read the code vertically down the page instead of across the page. So if we can make the lines of code horizontally shorter, but then vertically longer, it's stylistically preferable. Okay. Okay, what I want to do is illustrate a mistake that's really common at this stage. Before I do that, are there questions about this so far?
Yeah, now I did it a little differently, but it worked. I did the define statement underscore arg, and then in parentheses, I put name.
Yep.
Is that okay to do it that way? It seems like I'm like shortening it a step.
Okay. Okay. I want to show you. So that is okay as long as these two things match, right? If you have name here and name here, that is fine as long as your reference to the parameter matches the definition of the parameter. Okay, so
Okay.
the line 2 has the definition of the parameter. Line 4 has the reference to the parameter. Okay, so this is fine because they match. But let me show you a mistake that I see often, which is a mismatch between the parameter definition and the parameter reference. Okay, so I have this. I might say, okay, well, that works. That's fine. Looks like I got the expected output. So you might, like a lot of people make this mistake, and we really have to learn by doing, right? So you might say, okay, well, this is all working just fine. But then I run this. Why did that happen?
Cat.
So even though I have a new input, right, I have a new argument, which is cat, it's defined as the string Enzo, I'm still getting the output that says Tina can't get enough Python.
Go back up to your.
Yeah, let's take a look at the whole thing. So
yeah, because you're telling it to print a name, you're not telling it to print the STG, the string.
Right. So STG is the parameter reference. Okay, so I redefine that function, run this, I get the output that I want. Run this, now I get the output that I want to see here, because what I've done is define the parameter, reference the parameter, and they're consistent. So I've allowed this portion of the function to be a variable. Yep. I will be going over that a lot because it's just something to get used to as we continue to develop this idea of a function as an application that we want to be dynamic and versatile, right? So having that changeable part of the program allows the function to be dynamic and versatile. Dynamic in that it can take in an input, and versatile in that it can take in multiple different inputs of the appropriate data type. Yep. Okay, so that's parameter references. You might notice that problem 2 is pretty similar to a coding challenge, so that should help. Problem 3 has a lot to it. So how about we take a look at this one together?
Hi, sorry, I just had a quick question.
Sure.
I was wondering if we could just briefly go over the round for number 2, like the incorporating the round function in. I'm doing, yeah, it's just that part. I'm doing something wrong and I'm just not sure what it is.
Okay. So output
Have
we
you
want
ever
to
used the
return.
round function in Excel?
Say that again, sorry.
Have you ever used the round function in Excel?
Yes.
It's
Is it
kind
the
of the same thing.
Oh, okay.
So yeah, so what I would say is you're going to have a calculation in here. I usually call it PC for percent change. And then there's a whole bunch of stuff to fill in. And then it doesn't necessarily matter at what point in the function you do the rounding. But I find that it's helpful to first do the calculation to calculate the percent change. And then what you could do in this problem is just return the rounded version.
Okay. All right.
Yeah.
That makes sense.
Yeah, so that would be my recommendation there.
Okay, awesome. I'll try it out. That makes sense. Thank you.
Thank you for asking that very specific question. That's helpful. Appreciate it.
Yep, thanks.
Good. Okay. How about we do some of problem 3? Okay. So first thing we are doing in each of these problems is now I've added this, we've added this extra step of now deciding what the function parameter should be, and you get the choice. You get to choose what it's called, right? So you may call it X, but I'm trying to do better about making the parameter name different from the sample case, which it's not, I mean, it's okay to have an overlap, but I'm just gonna do my best to distinguish between those two things. So I'm gonna use data as the input, and that's gonna be the parameter that I work with. And then I will see that when I run this function, which is called summary, I'm actually going to be inputting something else, which is this data that I've given the label X. And then our expected output is supposed to look like this, okay? So this is a problem where we're going to do both printing and returning output. Okay. And I promise we'll take some time to further discuss the difference between using print and return and why we might use one versus the other. So, but this one has a lot to it. So let's just first now import some of the tools we want to use from the NumPy library. So I'm going to do from NumPy import the functions that I know I need. I need the mean. I need the standard deviation, and these all have to be specified according to this library and how they are defined. Okay, so standard deviation is defined in this way, and then I have median, and then I have the percentile. And there's also a maximum and minimum calculator that I can use, but Python already has a minimum function and a maximum function. So for simplicity, I will just use those. Okay.
Now, does it matter if you, where you import, I had imported it above my defined summary.
Oh, okay. So you're importing it outside of the function. That will not matter. That will not matter. There's different schools of thought about which is better. For our purposes, it actually won't matter. If you import the libraries within the function, you could say, well, maybe it makes the function a little more self-contained. And when we think about writing our programs, we want to think about realistic workplace situations. So often you're not writing a program for yourself, you're writing a program that could be shared with others. So it's always a good practice to think about how other people are going to be using the functions, and if it makes sense to import all of the tools within the function so that it's totally self-contained, or just tell the end user that, you know, these tools have to be imported in order for the function to run. So short answer, it really won't matter.
And then I had also imported, because we were doing so many different functions here, I think I brought in the whole library. I said
Yep.
import NumPy as
NumPy.
NP. Is
Yep.
that okay to do?
That is
Okay.
okay too. Yep. Yep. So there, you guys saw in the lessons, there are multiple ways you can do that. You can import it in different ways. When you import the whole library, you get everything. Or if you know that you're only going to need a couple of tools from that library, it's common to just import those tools.
Okay.
Yep. Okay. So let's start kind of building this structure. So I will do some of it, and then I will leave some of it so you could fill in the pieces that will be instructive, I think. So my suggestion would be to first start calculating the values. So I'll say M for the mean, and I'll just say that M is the mean of the data. And we're asked to round everything, right? So we're asked to round. Well, we'll get to the rounding in just a minute. Let's just try this for now. Okay. I'm gonna do a print, and I'm gonna look at the expected output and see what I'm asked to do. I can even be a little bit quicker here and do this. So let's see if we are getting anything so far. See if we can start trying to match the expected output. And then I can return the mean. Right, so let's now see what we're getting. Okay, okay. So I might even add a comment here because this is going to be a few different sections. So we could have a section for calculating the statistics that we want, and then we can have a section for printing the statistics and the statements that go with them, and then we can return. Okay, so that's kind of the structure. Let's do a couple more pieces. Let's at least do the first percentile. So we'll do the 25th percentile. I'll call it P25. Okay.
Why do you want to return it if you're already printing it?
Well, sometimes we want to be able to use the output in some other operation, and we can do that if we use a return statement, because a return statement preserves the data type. In a problem like this, we might need some context to understand the output. So there are times when it's helpful to print some output with a string or text that explains what that value is. But what we will see, and I'll go over this when we explain the difference between print and return, is that printed output is not usable. It doesn't preserve the data type. Okay, so we can return all of the values, and then we can use them, we can reference them, and I'll show you what that looks like.
Okay.
Okay, so percentile, if you look at the documentation or even just hover, you'll see there's two required arguments for this function. Okay, so the percentile function, we can look at it here. Let's go to that. Okay, so this is another outcome of our class, is learning to read documentation. So for this function, we can see that there are two required arguments. And then we can also see that there are additional arguments that are allowed, and you can read up on what those are about. But because the other ones have defaults, right? So if you don't supply a value, then the function can still run, and we'll use the default settings. Okay, so our two required arguments are collection of data values. That's our list. And then our second required argument is the percentile that we want to calculate. So that could be between 0 and 100. So let's implement that. So the list of values is called data. And the percentile that we want is the 25th percentile. Okay, so I know I'm not exactly going in the order that you see. There's going to be some more to fill in, but let's do this one. Let's print. Okay, so then we'll print P25 and we'll return that. Okay, so now we're starting to build the output that we want to see. I would just add one more thing, and that is let's look at how you can do the minimum. To call it MN is the minimum of the data. So this one's pretty quick to do. And then we can print the minimum and reference that variable. And then we can add MN here. So we're now building the pieces. Okay, so we have a little bit more of what we need. We run this. Okay, so now we're starting to get this. All right. So I won't go through all of the steps because I think this gives you the idea of what you need for this problem. Yeah, and I'll talk about difference between print and return in another setting that's slightly simpler that doesn't have as much extra.
So now what is summary X doing?
Well, it's doing all of these operations that we write. So we called the function
okay.
summary, and then we're building the operations that we want to do. Mm-hmm. So it's giving us a customized
okay. All right, I got you.
This is like, you know, maybe we're a statistician and, you know, we want a statistical summary that's specific to our needs. So we want to calculate these statistical results, and so we build that into a function. We call it summary. So then if we have built the function in the appropriate way, we should be able to use this for other inputs, right? So I had X, well now let me try Y. Let's do summary of Y. So now I have some different outputs here. So I have different values. This reminds me that maybe we want to be doing some rounding. So we can add rounding, we can wrap that. The round function takes two arguments. First is the value to be rounded, and then second is the number of decimal places to round that value to. So if I just wrap all of these in a round function with one significant digit, then I will be achieving the output that I want. So round, we only have to do it once here, and then we can reference those variables. That one is already rounded, but then we saw that these had too many extra digits, so we wanted to round those as well. Yeah, so there we go. Okay, so that's how we start building out the code for problem 3. Is this a good time to move on to problem 4? Okay.
Could you scroll up back to that problem for like 1 second?
Of course, yeah.
All good, thank you.
Yeah, no problem at all. Okay. All right. Yeah, so I think we can do this one, and then we'll look at print and return with this case, right? So this is a good one for us to do. We're going to calculate a restaurant bill, how much we have to pay. And you'll notice that I have this set up to actually accept slightly different results because people, I notice, calculate the tip in different ways. So I'm going to calculate it one way. If you use a different calculation, you just want to make sure that you can either get this expected output or this expected output. And the auto test and code grade are designed to accept either of those results. So I wanted to make sure you had something to look at to make sure you're doing the code right. Because this is less about the calculation and more about the idea of default arguments. Okay, so in one of our exercises, I showed this idea of default arguments. This is in our lesson. And this example shows two default arguments. So this is a mortgage calculator function. It takes a principal, an interest rate, and a number of months over which the interest is going to be calculated, right? So don't worry about this calculation here. Let's just ignore that. But what I wanted to illustrate is that default arguments can be used to make sure that there's like a backup value in the case that somebody doesn't supply those additional arguments. So with a mortgage, it might be reasonable to assume that the interest rate is going to be always going to be some fallback value, at least for a period of time, until, you know, they make changes, raise the interest rate on us. And it's also might be reasonable to assume that there's a specific number of months that are used for the term of the mortgage, right? So we can allow the principal to be a variable, right? We wouldn't want to set a default value for the principal because that's going to change depending on the home. But the interest and the number of months, those might stay the same. Okay, so I was able to run this with only one argument and then calculate the monthly payment. When I have default arguments, I can override them. So I could do this and get a different result. What I cannot do is this, which is define the function in this way without any default arguments and then try to run it with only one input. Okay, so the error says missing two required positional arguments, APR and N, because, you know, the interpreter knows that those are supposed to be supplied by the user when the user runs the function. So I just have to have these 6, 8, 9. And 3, 6, okay. Okay, so that gets that piece working. Okay, so then let's take that idea and try to build this one. So I'm going to call this, I'll just call it bill. So that's going to be our first parameter. And then I need the tax. This is the tax percentage. And we are told to make that default value of 0.0625. And then we are also told to make the tip percentage equal to 0.15. Okay, so 15%. All right, cool. Okay, so then I'm going to set up the calculation, and this is how I like to do it. I first like to find the taxed amount. So I'll say the tax amount is equal to, what am I going to call this? Is it okay? I'm going to call this cost, so I can stick to my calculation. So I have cost, tax, tip. Okay, so I'm going to take the cost plus, now I need to calculate the tax. So I'm going to use parentheses just to make it clear that this is a separate calculation. So I'll say this is plus the cost times the tax. And before I do anything else, let me just make sure I have something working. I'll just return this. Let's return that and see if we have something's working, and then we'll change it. Okay. Okay, so I have something. It's not the right value just yet because I still need to add on the tip. And I'm going to call this total bill, which should then take the taxed amount and then plus the taxed amount times the tip percentage. That should add on the amount of tip that I want to include. Okay. So let's see if I'm now getting the expected output. Almost. I'm supposed to round this, so I better round it. I'm just going to round it here in the return statement, which I can do. And I'm supposed to round this to 2 places. So I'll do that. And then looks like I have the first expected output. Okay. And then for those who calculate this a little bit differently, they might have, I don't know, they might do this. This is the alternate approach. Let me see if I can get that right. So some people
I got the alternate amount.
Okay. So the other way would be like this, to calculate the tax and the tip just based on the original cost, which is okay too. So we could do that times the tip, and you know, this could be written out more efficiently, but you know, I am not one to do things quickly and efficiently at this stage, not just yet. We care more about being able to follow the logic. Okay, so here's the other, these are the other results that you would get with the alternate solution.
Oh my God, I had like 10 more steps and it wasn't right.
Well, it's a learning process for sure.
Holy, yeah.
Really.
Hurt my
And
brain.
it's hard because you see the solution and you go, oh my God, that makes sense. Why didn't I think of that? But no, you're not expected to at this point. Let's go to this.
A lot more. Way more words.
Okay. I'm just adding some markdown here. Okay. While we're here, I think I want to look at this idea of print versus return, because this is probably a good opportunity for us to do that. I'm just going to clean this a little bit. And let me just say, okay, total bill equals rounded version. So I basically defined that variable twice. And then rounded it one time. Okay, so I have something working. I'm going to add a block of code. And I'm just going to do let's do calculate bill with $10. Okay. Okay. So we've talked about different ways to output values from a function. When we do a return statement, we end up preserving the data type. Okay, so in Python, the data type is automatically detected and the fact that I'm doing mathematical operations is indicative of the fact that the data types that I'm working with are floats. So I'm going to just call this result equal calculate bill 10. Okay. So I've basically created a value by running this function. Now, the result, which I saw when I ran this the first time, was $12.12. That doesn't, does that make sense? Yeah, that makes sense. Okay, well, if I have a return statement, I could do something like this. Like, let's say, I changed my mind. The service was really, really good. I'm going to add another $2 onto that. So after I've already done this calculation, something happens and then I add $2 and then I have to, change my records after the fact by adding this extra $2. So then I get $14.12. I can do that if I have a return statement. I can't do that if I have a print statement. Okay, so if I just change this to now printing the output, then running that result. Okay, so I got that result, and now I want to do this operation. Well, I get the error unsupported operand for addition between none type and integer. Okay, so the total bill was a none type because I use this method of outputting the value. The integer is the number 2 here. Okay. So what this illustrates is that printing output from a function generates a none data type. This is not compatible with other operations in Python, is how I would explain that. So printing is kind of just like generating a snapshot, like taking a picture of something to show us what we have. It's a terminal way of outputting a value. Whereas a return statement preserves the data type. And we spent our first week learning about data types. We learned about strings, we learned about numbers, we learned about Booleans, and there may be cases where we'd like the output of the function to be usable in other parts of the program. So if that's the case, then we should use a return statement. Okay. Well, there's also nothing wrong with having both a print and return statement. Why might we do that? Well, kind of like what we saw in the last problem. We might say something like, you will pay this amount, have a comma, to add some context, right? This makes the output somewhat more readable and understandable, but we could still then return. We could return the total bill. And then we won't see the output, but let's see if we can still do this. Yeah, so we can still do that operation. Yeah. So that's a look at print and return. The moral of the story is if you don't use a return, you will not generate usable output. The data type will not be preserved. Okay. So that's a little extra. That's kind of going beyond the problem. The problem itself is about default arguments, but this gave us an opportunity to look at that kind of important concept. Okay, Well, we're right about at 8 o'clock. So here's what I'm gonna say. We covered a lot. You have some more time to work on this, of course. And I had a lot of meetings today. They were almost all filled with students, and then I had some other meetings I had to go to that were not office hours. So I didn't have as many appointments today as I usually do. I didn't hear from a lot of people, so I'm guessing that there are some students still who will still want to work on the assignment and may have some questions. Okay, so I do have a little bit of time tomorrow afternoon, a little extra. So reach out. If you get to me early, I might be able to meet with you tomorrow afternoon. If not, I may be able to send you a quick video helping you troubleshoot your code. So when I do that, I look in CodeGrade and I point out the issue and try to get you on track. So I'd be happy to do that if you want to email me between now and tomorrow evening, or probably tomorrow mid-morning. I should be able to get to you. I have this workshop from 9 to 12 that I have to do, but I will, even though I'm not supposed to and I'm supposed to be paying attention, I will be looking at your emails.
And now something that you had mentioned to me when I emailed you, others might benefit from, you said that we should not be using an input statement when we're uploading to CodeGrade.
Yeah, so an input, the intention of an input is to kind of make it easier for the user to interact with the code, right? And it really requires that somebody be working with the code in a dynamic way, providing inputs. And that's not compatible with CodeGrade. So CodeGrade is just going to run the file from start to finish. So the way it's set up, also functions already have a mechanism for an input, right? So if you're writing a function and you have parameter values, there's no need for inputs. So you can just leave that piece alone. So as a rule, I wouldn't put inputs inside functions. I can't think of a case where we would need to do that. So let's leave that out. Let's leave that out of our functions. I think it'll just cause problems. Thank you for bringing that up.
So I have something super random real quick. So for some reason I've had my brain's been not working. And so I've been having a problem with number one. Everything else looked fine. I've been resubmitting while we've been on this call. I went from an 82 earlier to I just submitted and now I'm at a 0. And the only thing I changed was number 1. And I'm about to literally throw my computer out the window. So because how did I go from an 82 to a 0?
Okay. Well, let me stop share. Yeah.
And at the end of the day, it's not really, I'll get number 1 figured out. I just need to calm down, but I'm so confused at how I went from an 82 to a 0.
Well, same thing happened to me. If you have one thing wrong, it'll 0 you out.
But that's what I'm saying. Number 1's been wrong for me the whole night, and I've been playing with it while we've been on the call, but it's been scoring at an 82.
Yeah. Okay. So we'll figure it out.
It's fine. I think I just, like you said, I think you just need to walk away and come back and it'll.
Okay. So I'm looking at it now. Let's see.
Oh, okay.
So I don't see, there's no errors in problem 1, but there's something happening with the check price problem, which is weird that wouldn't show up before, but let's just see. So maximum recursion depth exceeded. So maybe there's some kind of infinite loop happening. Is it okay if I share?
I was just playing with that one and I see that error now in my Colab. So.
Oh. Okay. So
yeah,
Check price, is that 2? Problem 2? No, that's percent
Problem
change.
5.
Check
And I know what
problem
I think
five?
it's the return. Nope. I'll play with it, but if you see everything looks fine in 1 through 4, then
well, what I can see is, yeah, I can see that there's not an error until problem 5. So, oh wait, I did that again. I didn't want to show everything. Okay, so I think what I'm seeing in line 8 and 9 in problem 5, okay, we've got M, current, that looks good, that looks good. Okay, line 10, you have return, check price, and then purchase current.
it's an indentation.
Let's remove that, and just in line 9, you want return false, and then you want to remove the line below. So what's happening is basically uncontrolled recursion. So you have the function referenced within the function. So it's like infinitely running. So yeah, if you delete line 10 and change line 9 to return space false, I think that'll clear the issue. Otherwise, I think you have something good here. Yeah. Looks good.
All right, I will do right the second, actually.
Oh, and problem 1. So I just went right to the error. I wanted to clear the error. Problem 1, we actually don't want a function parameter in problem 1, so it should just be statement with empty parentheses.
I'm sorry, what was that?
Problem 1, we don't want
I've been playing with that all night with empty parentheses, open parentheses, and it keeps telling me that nothing is defined and.
Yeah. So let's just not even make this too mysterious. Let's just do problem 1 together. This, because yeah, so others ask about this too. So let's do that. So we have this is the function, right? And then you might have been seeing an error because maybe you were running the function with an argument, but all we're doing, and this is like so simple that people get thrown off about it, right? So there's no function parameter when we write the function. There's no argument when we run the function, and then this is all it does, which you look at it and you go, well, that's so stupid because I could have just printed.
Oh, I've ran this like 7 different ways. I've been putting X equals the statement, and I've been doing this a million different ways.
Overdoing it, yeah, yep. So we don't want to go there. We don't want to start throwing things. We don't want to go to anger management. But I know we all start to feel that way. Yeah.
For number 4, when you were doing the problem, I don't remember, but did you get the exact expected values that I was asking for in the first set of it? Because I wrote the same code you have, but I get 37.38 and 25.61. So I get the second part, just not the first part. Yeah, mine's that exact.
Did you use the first calculation?
Yeah.
Okay. So, and then you're saying it's not.
Yeah, it's showing up as like the second part, like 25.6 when I'm getting that, but not 24.44.
Okay. Do you want to share?
Yeah.
Okay, cool.
Am I sharing it?
Yeah. Thanks. Okay, your tax is 0.625. You want it to be 0.0625.
Okay, I see. Okay, thank you.
Otherwise, the calculation looks right to me.
Okay.
Yeah.
Thank-
Of course.
Yeah, okay, yeah, that was it.
Great.
Thank you.
Great. Thanks. Okay. All right. I guess we're good. I would say keep being awesome. What you're doing is really hard. And it's summer. And this is new for a lot of people. So I appreciate all the hard work. Please do reach out. And I know tomorrow's the deadline. So I'm happy to keep an eye on things. And I should be able to connect or get back to you in the early or mid-afternoon tomorrow.
Is Tuesday always the deadline for assignments?
Yeah.
Okay, I just wanted to see if it was consistent.
Yeah, it is. It was just that first week that was different.
Okay.
Thank you.
Thank you so much. It was an awesome session today. Appreciate everybody being very engaged and helping
Much appreciated.
develop the code together.
Definitely shedded some light. Hopefully it was enough. Let's go back at it.
Great. Well, let's say go team, and we'll keep at it. I'll see you next time.
Sounds good.
Thank you.
Bye.
Thank you.